Okay. Can anybody hear me?
Yes.
Maybe?
Yes.
Okay. Thank you.
I
All
have
right.
a question.
If you're here, put your name in the chat. If you're not here, don't put your name in the chat, so that I have a record. Let's see, and we're recording. Okay, I'm a little bit early, so we're stalling for a couple minutes here, for just a minute or two, and we'll see how it goes. Oh, the assignment box. You know, when I set up assignments or forums and things like that, I have a lot of choices in Moodle, and so sometimes I hit the wrong choice. And so I think it will take the assignment now, which should be a file submission, like a photo file. I had made a mistake, and I didn't click the box, or that I clicked it and then unclicked it somehow. And so so I think it's fixed. If not, try submitting a file, and if not, give me another thing. For those of you that sent me an email, thank you. Thank you for the heads up. Okay, so what do we got here?
Can I
We
ask
still
you a
have a
question
minute or
after
two to wait.
class?
Okay, again, put your name into the chat to make sure that I don't screw up and mark you as not being here. So that helps me quite a bit. Okay. All right, so I have 9 o'clock, so let's start off by looking at the schedule. Okay, so I'm gonna share the schedule. Does anybody see the lecture topics and assigned readings? Please give me a thumbs up or just a yes if you do see it. Anyone? There, thank you, Tessa. Okay, so we finished. I'm going to go up. So we've finished with the first 11 chapters of the textbook. That's like 450, 500 pages, something like that. And now we're starting with the nervous system. So exam 2 is done. I'm working on correcting that. And we're working on the nervous system. And if you look down here, you can see the rest of the course is really nervous system chapters. And so there's chapter 12, 13, 14, 15, and 16. We have one more 1 hour exam before the final, but it's all nervous system. And unlike other chapters, a lot of this is physiology. So there's a lot of physiology coming up. How does this work? And so the nervous system is more complicated. It's longer. We're going to go into more detail here. There's really a chapter of anatomy, and then the rest is how does it work? So it gets into quite a bit of detail, which makes sense because this system controls other systems. And so we've got this big long section to go on the nervous system. So that's the rest of the course, and you'll use a lot of that nervous system stuff when we start talking about other systems that we'll kind of refer back to. Well, that's controlled by the nervous system, and this part of the brain controls the heart, or this part of the brain controls the diameter of blood vessels, or the hunger center is in this region here, and here's the negative feedback system. So we're going to talk about the nervous system a lot in anatomy and physiology too. Okay. All right, so then let's go look at the list of words for this week. So chapter 12, nerve tissue and the nervous system. There's a huge list of words. And many of these are really, really unfamiliar. And so this is, in anatomy and physiology, I give you more new words than you would get if you take second semester Spanish or any of these foreign languages. It's important to recognize how difficult this is and how much time this takes. You know, and for people that are doing it, I appreciate it. You know, I know to get an A or B on this, you have to put in lots of time. And so this chapter is no different. It pays off. You know, healthcare jobs are good jobs. Um, these are also these will help you take care of family members. You know, I've been very grateful that I work in an area where I have access to healthcare professionals, and that I can talk to them kind of using the language they use. It's very helpful, but it is difficult. There's lots of stuff here to do, and then, you know, make no mistake about it. Okay, so there's just this blizzard of details that's coming. Let's, in chapter 12, it starts. And so let's kind of look at this in a big overview. One of the things to know in this chapter is that they're going on about, you know, if you stand back, some of the big parts of this chapter are easy. They're easy parts to get. And some of the stuff that I'll ask you on the, you know, on the next exam about this chapter are not that hard. So for instance, one of the things I'll definitely ask is about general functions of the nervous system. Okay. And so this is not that hard. Okay. So one of the main functions is that the nervous system carries sensory input. Okay. That things from the eyes, from the ears, from the skin, this sensory input goes along nerves and it goes to the central nervous system. Okay. The other kind of just carrying things out function is, your book calls this response, but more often it's referred to as motor, that the nervous system activates muscles and glands. Okay, it carries the response that's desired from the nervous system. So it's carrying things to and from the central nervous system. Things that are coming in from sensory organs are being carried, and things that are going out to muscles or to glands. Okay, and that's really the main response type stuff. And then the other part is integration. Okay, and that means the nervous system makes decisions. It weighs multiple inputs. It weighs, you know, what's going on externally with what's going on internally, and it uses that to make decisions about homeostasis. It uses that to make decisions about, you know, should this, you know, should I, your conscious decisions are based on stuff like that. Memory and thought, these are all integration. And so it involves multiple inputs, kind of deciding among them, choosing courses to follow. And this can be really, really complex and involve multiple regions of the brain or spinal cord. But generally, integration is most often, not always, but most often in the brain and spinal cord. Okay, so that's not that hard to get, and it's a big part. The other really kind of, I don't want to say it's an easy part, but it's what are the divisions of the nervous system? So basically, we can divide the nervous system up into a central nervous system, the brain and spinal cord. This is the part that's encased in bones. It's the part that's floating in cerebral spinal fluid and is covered by membranes called meninges. It's the part where most integration occurs in that central nervous system. Okay, and then the other part is the peripheral nervous system. These are it's nervous tissue outside of the central nervous system. There's no bony case around this. It's not floating in cerebral spinal fluid. Most of this is sensory and motor. And so it's mostly carrying those things, but there are some areas where there's some integration. Okay, and so you have these two different functions. You can even make up more divisions of this. And so when we talk about the central nervous system, you know, we mostly talk about just integration stuff. But when we talk about the peripheral nervous system, often we talk about sensory and motor divisions. We sometimes talk about the autonomic system. The autonomic system is a motor system that controls things you're not consciously aware of. Your smooth muscle, your glands, your internal organs, things like that. And we also have kind of another special system outside and it's largely motor, but the enteric nervous system, we have a lot of nerve tissue associated with our intestine that's outside the brain, but it communicates with the brain through all these nerves. So we have these different divisions, and these are usually just parts of the peripheral nervous system, although you have central nervous system stuff that's responding and controlling some of this. Okay, so that's doable. It's, central nervous system, peripheral nervous system, sensory, motor, autonomic. These are just divisions. Okay, and this was the illustration I gave you. The brain integrates the input, the sensory input, the smell, sight, and sound of a bear. And that sensory input is carried by peripheral nerves to the central nervous system. And then the brain decides on responses, and these go out through the motor divisions. Some are autonomic. Well, it'll make your heart pound. You'll start sweating. You'll have a big release of adrenaline. Okay, that's autonomic. And then depending on what the conscious part of your brain decides, you may decide to consciously run away or back away, or maybe you'll stand up and shout. Don't run away from a bear. That would be fatal. They're faster than us. Okay, so part of this chapter is the general functions and those divisions. That's an important part. Okay, and so don't forget that's understandable. And Mr. Nowicki's always going to ask the divisions and those general functions. That's very likely to show up on an exam, and it's you can approach the nervous system in that way, and it can build on the things you already know. Does anybody have any questions?
Could I ask you a question about a worksheet after class?
Anybody? You could chat a question. Let me look at the chat. I haven't looked at the chat for a while. No. Okay. If you showed up late, make sure you put your name into the chat so I know you're here. Okay. Let's take kind of another look at the other part of this, the tissue part, and how the tissue functions. That's the hard part. Let's look at that, but let's kind of step back as we look from it and look at that not in kind of such a huge amount of detail that we're overwhelmed. Okay. Right. So the other part of this is that nerve tissue contains different types of cells. They talk about the neuroglial cells. That's important. The most important functional cells are neurons. Okay, neurons are cells that can transmit messages, and they can do it fast. Okay, all neurons are large, long-lived cells. They have a big cell body, and then they can have extensions off the cell body. Okay, so neurons are the primary cells. There's neuroglial cells, yeah, but it's neurons. So hard part here is that neurons function. The transmitting message is an electrical transmission that allows it to send it from one end of the neuron to another. Okay, this is just like muscle cells. Neurons do action potentials. Okay, and action potentials is a change in the charge, the membrane charge or membrane. Okay, and they can do this very, very quickly, and this change in charge is due to ions moving through the membrane through gated channels. Okay, these gated channels are specific for certain types of ions, okay, and they can be opened and closed. And so to start an action potential, we use ligand-gated channels, okay, which means it binds to some molecule outside the cell, a ligand, okay, that's a signal molecule. It binds to that signal molecule, and that causes the channel to open. Okay, and so that's the initial thing that happens. And then that once that depolarization reaches a threshold by sodium moving into the cell, that causes other ion channels that open because of a change in charge to open. And these are called voltage gated channels. And so this is what causes the spread. Okay, and so the action potential itself is due to the opening of
She
sodium
gonna get a
channels.
fucking whooping,
Okay.
Jesus.
The charge is quickly reversed in a repolarization phase, and that's due to the closing of the sodium channels and opening of potassium channels. And potassium diffuses the opposite way of sodium. It goes from the inside to the outside, and that restores the resting potential. Okay. All right. So it's just like muscle cells have an action potential, nerve cells have an action potential. Okay. And then when the nerve cell wants to signal another cell, okay, it does so at a synapse. Okay. And a synapse is just the junction between two neurons. Okay. And these, sometimes the signal can electrically change from one cell to another, but most times it's due to the release of one of these chemicals, okay, these neurotransmitters. And so acetylcholine, which we've already learned about from the muscle cells, is a neurotransmitter, okay, and some neurons respond to acetylcholine, okay. With these neurotransmitters, they're always going to work by a receptor. So the cell that's receiving the signal has a receptor. And usually that receptor is going to be an ion channel that opens when the ligand binds to it. Okay. And so there's different neurotransmitters. Some neurotransmitters open ion channels that cause cells to not have potentials. They're inhibitory. Some are excitatory. It depends on the receptor. Okay. That's the long and short of it, is that it's you have action potentials and you have this signaling and signaling through neurotransmitters. Okay. And so there's a lot of details in there, but the basic stuff is, you can say it shortly. There's an action potential that spreads across the surface of the cell due to the ion channels that allow sodium to move. Okay. And then one neuron signals another neuron by way of a neurotransmitter. And there's lots of these neurotransmitters, 50 of them, maybe 50 different types. And you can imagine that these would be really good really good targets for drugs. Is that, if something's going wrong, maybe it's because there's not enough of a neurotransmitter, or maybe there's too much. And so we can do things that alter neurotransmitters and try and affect what goes on in different nerves. Sometimes we can use, if we want to affect the heart, we might use a drug that affects the receptors that the heart has. And so, these are important targets for drug companies. The drugs of abuse, things like nicotine, cocaine, amphetamines, heroin. These things are all working on this neurotransmitter receptor systems, and they all alter specific neurotransmitters, and so they make people feel good, at least for a while. With all those drugs, though, there's really downsides that, like for the opioids, if people regularly use those, what happens is that they have they're triggering these receptors, and after doing this a while, the cells start making fewer receptors because they've been triggered so much. And so when the people aren't using the drug, they feel really bad because these kind of receptors that are associated with these good feelings get harder and harder to activate without the drug. And then it takes a higher and higher dose because the cell has fewer receptors. And so they develop a tolerance that means they have to take such large amounts that it's easy to overdose. And then when they're not on the drug, they feel really bad. They have these withdrawal symptoms and things like that. And so, you know, this explains a lot of otherwise what seems like crazy behavior. So, does anybody have any questions? Anybody? You can chat questions. Okay. You know, I look, well, nothing. People's names, that's good. Okay. All right. So chapter 12 is a really hard chapter. There's lots of stuff in it. You know, make sure you know the functions of the nervous system, the divisions of the nervous system, and then be able to explain the how neurons function. Okay. There's an action potential, and then what happens at the synapse. I have very nice animations that you can watch several times. I mean, they go fast, but it can help you. There's really good explanations of the nervous system there, so it's worthwhile to watch those. They're in some ways better than looking at diagrams because you can see kind of what happens, and the diagrams are kind of static, and whereas the animations kind of it flows nicely, and so that's very helpful, at least for me. I liked cartoons when I was a kid. All right. Okay. Oh, I wanted to say something about the schedule. Let me look here. So today's the 24th. We're going to have lab next week on Tuesday the 27th. Okay. But the following Tuesday, the 3rd, is the election day. And when I made out the schedule, I forgot to note that the college is closed. So on November 3rd, that's a Tuesday, it's a normal lab day. We won't have lab that week. I'll put a movie online or something like that, but it's I won't just throw extra stuff at you. I'll do that, and so we'll see. As far as things go, I think the COVID stuff, at least in Stevens County, is stable. So I think we will have lab next week. You know, we'll see. Okay. All right. Any last chance? This is your last chance for questions if there's none. Okay, I'm gonna, it'll be a shorter meeting, you know,
Wait, I have a
little bit,
question.
not bad.
Can you hear me?
Anybody? Okay, all right. Yes, okay. All right, so that's all. Let me think here. Okay. I'm going to end the meeting now. Thank you, and I'll see you next week. Hold on. Okay. Okay. It's hard for me to do things in the chat. Okay. All right. Okay, so that's it for today, and we'll see how things goes. Okay, and one last chance. Put your name into the chat if you haven't already. Okay, thank you, and see you next week.